we got the cam bearings in, we got the block cleaned up, honed. So right now, I got all the lower end bolts cleaned, the caps cleaned. So let's put some bearings in here, set the crank in, and check it all with Plastigauge. Make sure that you have blown all of these bolt holes out with compressed air, some solvent. You don't want anything down in those holes. Yeah, I went with P series Clevite bearings on this. Good steel back bearing. I like them, they work well. So obviously your ones with the oil holes go in the block because you have the oil holes in the block. Get them set down in there. Make sure the little tab is in the hole. Your middle bearing is your thrust bearing. On this particular set, they have a side that has 2 oil grooves on the thrust side on one side and 3 on the other. So I had to make sure to put the side with the 3 grooves toward the back. And with the tab, it'll only go in that way. All right, you got the bearings in. Now we can set the crank in place. Make sure all the journals are clean. Gently lower it down in there. No oil, because we're just checking the clearances right now. For this, you want to use the green Plastigauge because it goes from 1 to 3 thousandths. And basically you're shooting for 1 to 2 thousandths on these bearings. So you want to take a little piece of this Plastigauge. See it right there? Woo! Yeah, can't see it. Lay it across your bearing surface. Just like that. And you've got your cap cleaned up with a new bearing in it. And you fit it down in there. And draw that down. And just snug those up for now. That'll hold the Plastigauge in place. Then we'll go through and torque everything down to spec. And then we'll take it back apart and measure. So right now, I just need to go ahead and repeat that on each bearing. Plastigauge is in, all the mains. Caps are all on, bolts are in loosely. So now we need to go through and tighten everything in sequence. And the factory service manual says to tighten absolutely everything, including the small bolts on the perimeter. Seems like a little bit of overkill to me, but it may, being an aluminum block, it might shift the shape of the bearing bore a little bit. Who knows? It's no big deal to torque them all down. There is a specific sequence. Got it here. The numbers to go around. You do the inner ones first. There are the torque specs. You torque them foot-pounds, and then you go to degrees. The first torque is 15 foot-pounds, so I would not suggest using a 1/2 inch torque wrench that goes from like 10 to 150 because you won't be able to feel the 15-pound click very well at all. So I got a newer torque wrench that is, I think, 5 to 80 foot-pounds, 3/8 inch drive. Works really good on these lower torque settings. So let's go through and get the inner ones torqued. How does it say? Yep, you do the torque and then the angle on the inner ones, then torque angle on the outer set, and then the last perimeter bolts to 18 foot-pounds. Well, I goofed up and forgot to turn my camera back on. I missed recording tightening the inner series of bolts, but it'll be the same thing as I'm doing on this outer side, except at a different degree. They go in the pattern I showed you. They tightened to 15 foot-pounds, and then I went back through in the same sequence and tightened them to 80 degrees. So now we're going to do the same thing on this outer set of bolts, the ones with the little studs on them. You still go to 15 foot-pounds to start, but then you go to 53 degrees turning on the final pass. So let's hit them with the torque wrench. I definitely like this smaller torque wrench for these lower settings. Gets a very nice, definite click. In the past, on these lower settings, if they were just high enough I couldn't use an inch-pound torque wrench, I would usually use a beam torque wrench so I could watch it creep up on the right amount. But this clicks just perfect. Okay, now we'll go back. Same pattern, take them to 53 degrees. I have this little torque degree wheel. I like this kind with the flexible shaft instead of the kind that with the rod that just pushes up against something. This one seems to work for me a lot easier. And we'll put that on 0. Tighten the nut down and take it to 53. Next. And unlike the head bolts, I've never found anywhere that says, even though you're using a degree to set the final torque, I've never seen anywhere where it said these were torque to yield, had to replace them. Factory service manual, in fact, doesn't say anything about it. And it also has you go through and tighten them like this to check the bearing clearance and then just undo them and then tighten them right back up for final assembly. I'm sure a ARP stud kit or something like that would be a nice addition, but at the power level I'm at, not necessary. And that's all of those. Now we can take and do all the outer ones to 18 foot-pounds. These would be the only bolts you might consider changing because they do have a sealant around the head when they come from the factory because they do go through the side of the block. If you don't have some sealant under there, you can have an oil leak. That would be the only reason to change them. And you can always put some sealant under the head when you do final assembly. Now, I am just running these in to where they touch. Now these don't have a specific order to go in. Just says to do one side of a bearing cap and tighten the other. So we're going to start in the middle, boom, 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 and work our way around. All right, now that we have everything tightened to spec, we'll take everything back loose again, pull the caps off, and look at the Plastigauge. Okay, one thing I hadn't mentioned so far is that you absolutely, during this Plastigauge testing, you do not want to turn the crank because it will smear that Plastigauge and you won't be able to get an accurate reading. The way the Plastigauge works is that little strip of that green stuff, when you squeeze the bearing on there, it squishes that. And the tighter the clearance, the farther it squishes it. And then what you do, see if we can get this into focus. You use this little card, which is part of the packaging. And the wider it is, you can see you've got the thousandths, 1.5 thousandths, 2 thousandths, 3 thousandths, depending on how wide it is. So you measure how far that Plastigauge is squished, and it'll tell you what kind of clearance you've got. So right now we need to carefully pull the first cap here. And right there you can see where it squeezed the Plastigauge. And that is a little bit under 1.5 thousandths. probably just a little bit less than 2/1000. See how it's just slightly wider. That green one right there is the 2/1000 section. See, it's just slightly wider than that, but it is less than the 1/5. So it's between a 1/5 and a 2/1000. Which is exactly where you want it. Because your range was 0.0008, which is less than what the Plastigauge will read, and your outer limit is 0.0025. And we were a little less than 0.002. So it's perfect. It's right on the money, right where it should be. I like them around 2/1000. That's a good clearance for a bearing. You don't want them too tight. You don't have as much oil film through there. Racing motors, they actually run bearings that have an extra thousandths of clearance, but we don't need to do that either. So 2 is good. So now I just go through and check each one after that and make sure they're all the same or all within spec. And you do want to take some solvent and wipe that off the journal and wipe the residue off the bearing before you do final assembly. Okay, before putting the crankshaft in for good, 2 things I want to do is change the timing gear. We also need to pull out the pilot bearing on the other end. They make a special tool that fits in just for these, but I don't see why the 3-jaw puller won't pull it off, so we're going to try that. That's the same spacer I used there to take the harmonic balancer off. There we go. Okay, this is just a stock replacement melling gear. Not any kind of performance improvement. Just slides on, engages the key there. Put a little bit of anti-seize on it just to help it slide on. Now we need to press it that last probably 1/4 inch on there. I'm going to use the tool for installing the balancer pulley, which is basically just a bolt or a piece of all thread that screws into your crank. Now screw that in all the way. That way you're fully engaged in the crank threads. And then what I'm going to do is use the old pulley or the old sprocket as a spacer. Got some flat washers and then a nut to go on here. Now we can start cranking that down, pushing the gear on. And you want to use the stud. Piece of all thread in there because you do not want to try to push that on with your crank bolt, relying on pulling against your crankshaft threads as you put that in there. You want to have that all the way installed. That way you're not stressing the threads. The load is distributed on all the threads in the crank. It's very important. You could end up pulling part of your threads out of your crankshaft, and that makes for a very bad day. Now we just start on this around. And the new gear is on it. Now I compared this sprocket. There was really no good reason to change that. When you put the chain on, I can't tell any difference in slack between the old one and the new one, but it was a good chance to show you how to change it. And these aren't very expensive anyway. So went ahead and changed it anyway, just to be sure. Next up, we need to pull out the pilot bearing. Well, I moved the crankshaft out of the engine because I can't get to the pilot bearing because of the engine stand. Now, I have a pilot bearing puller that I got from AutoZone. It's got the two arms that come in there and spread out. And then you use a slide hammer to pull it out. I don't think I ever managed to get a pilot bearing pulled out with that. These LS's, I usually end up having to cut the bearing out. Then you cannot use the bread method where you pack that full of bread or whatever and then smack it with a dowel and push it out, because there is a press-in plug on the inside of that crank. You'll end up pressing that plug on out and have all kinds of problems. So what I got last time I was at Harbor Freight, I got a different kind of puller. It goes in there and then pushes up against the crank, and we'll see if this works any better. Okay, you run this piece out here. That lets the two ears go together. You stick them in there, and the center part pushes up through there and spreads those puller ears. So back that out, get it in the bearing, tighten that up to where that spreads out. Nice tight fit in the bearing. And run the nut in till your arms here are up against the crank. Now hold on to the handle here. Start tightening this. And now I felt the end of the clamp engage the bearing. And it did absolutely nothing. Pull the guts out of the bearing. Since that is a needle bearing, it tends to pull right through. Tends to flatten out the cage on the inside and pull right through. Problem I've had before with the slide hammer version. I'll take the grinder to these and give them a little more lip right there to where they'll grab better. Okay, that gave them a little more of a hook at the end, so try one more time. Turn it a little bit so I'm grabbing a new piece of the bearing. Whoa, it's working. There we go. It actually did work. Problem is you're grabbing on, you're catching that thin metal of that needle bearing, and it's just pulling through there. If you were grabbing this outer part, which is I think what we ended up doing, then it comes out a lot easier. But my little $20 tool worked. And that was a whole lot easier than going in here with a die grinder and cutting it out. Now, while that was a little bit of a pain underneath the car using the die grinder, yeah, this would be better. I'm also going to do a little research. I think you can use the older style C4 pilot bearing. Well, it's a bushing. And honestly, in this situation, I never had a problem with the bushing. But I have in an old Bronco 2 had to pull the whole transmission out because the needle bearing came apart and was messing with the input shaft. But I've never had any trouble with bushing, so I may try to put a bushing back in this. All right, the tool was a success. I'll throw that on the bench for later. All right, now that I got those two things done, let's put this crank back in there for good. Put some assembly lube on everything. Be sure to put it on the sides of the thrust bearing. And we'll start putting the caps in. Lube up their side of the bearing. Make sure everything's in the right spot, facing the right direction. And just taking these down to where they just touch. I'm going to use a wrench here to pull them down evenly. Now everything's down, and since this block here, the thrust block, can move just slightly on its on the bolts, we're going to pry the crankshaft against the block. Now we'll get both pieces even. And now we're going to check that gap. There should be a gap between the crank and the thrust bearing. So we're going to stick a feeler gauge down there and see how to check the gap. According to the manual, that gap can be anywhere from like a 1/1000th to a 8/1000th. There's 2. Fits in there nicely. 2/1000 fits just perfect. Depending on which way you push the crank. So that's good. It's just like the main bearing clearance. You want to have room to get some oil in there. And the reason they put the 3 grooves on the backside is because when you're pushing the clutch, that's all pushing forward on the engine on that thrust bearing. So now we can go in and put the rest of the bolts in. Okay, so it's just the same pattern, torquing everything down as we did when we tested it. I'm going to look through all the holes. I'm not going to put in the side bolts yet because they all have to have sealant on them, but everything looks like it's lined up just fine to where they will go in. Just like before, all the inner bolts in the pattern 20 to 15 foot-pounds. Since we're not checking the Plastigauge, anytime you tighten something up, make sure everything still turns freely. If something binds up now, you'll know exactly when it happened. So now we go back through, same sequence, inner ones, take those to 80 degrees. They follow the same pattern. Do the outer ones. They go to 15 foot-pounds also. Now back around again with the degree indicator. These all go to 53 degrees. And there's the last one. Okay, I cleaned and dried the underside of all the bolts for the sides to make sure the sealant holds good. I'm going to go through and make sure there's no oil left in the holes. Then a little squirt of brake clean. And then blow them all out nice compressed in. Here for these side bolts, I'm going to use anaerobic gasket maker. This stuff, anaerobic, it cures in the absence of oxygen. So when you squeeze the stuff between two bolts or anything like that, that's when it cures. And it's a little easier to clean off later than if you use like silicone. And it looks like jelly. Put some around the base of each bolt. Put them in. All right, these all get torqued to 18 foot-pounds. Do one side of a cap, then the other. Turns perfectly smooth. Just the drag of the oil is all I feel. Just like it ought to be. So that is crankshaft installation. I'm real happy with the way this went together. Next video will be probably putting the pistons on the rods, because we got the new pistons. They're press fit. We'll have to press off the old pistons and then fit the new ones on using heat. So be watching for that one. That should be the next video. Till next time, thanks for watching.